So Chapter 2, Lesson 5, the Scalable Smart Contracts. Let's talk about scalability. We've already talked in the first chapter about the grand idea of infinite horizontal scalability of the entire Ton blockchain. But what does this really mean, and how do you take advantage of this in your applications? In Ton, you really have a very specific guarantee around scalability. Ton guarantees you that it can scale down to granularity of individual contracts. So if you have two separate accounts, then they could exist potentially in separate shard chains operated by separate consensus groups of validators. And therefore, operations on one contract will not create a bottleneck for operations on another contract. And then the Ton network obviously will take care of all the message routing between them. But this is really the only guarantee that the Ton gives you. It doesn't give you any tools to make your own contract within the code and data that you store inside your application any more scalable than that. So it's your job to take advantage of the entire scalability of blockchain and not create bottlenecks in your own contract. Now let's take a look at the problems that you may run into when designing your application. One of the obvious problems for people who are coming from traditional systems, the large-scale web databases, or from Ethereum, is that they design the contracts as monolithic applications with their own variable length storage. So for instance, in Ethereum, the token is implemented as a banking ledger, where you have a single smart contract that contains the list of accounts, and then if you have 1 million users, this list will be 1 million rows long, and there will be an entry for each user saying what is the address of the user and what is their balance. And then designing such contracts is pretty easy and straightforward. You have atomic transactions, you deduct from one balance and add to another, and it's very easy to design and see how the system would work. However, this model will not scale in Ton because you would put this long list in a single contract and you will immediately run into issues. First, you will have progressively growing cost of rent for all of this data that you store in your contract, and it will be hard for you to spread out this cost among all the users. And second, every time the user comes along and wants to make an operation with this contract, they will have to pay the larger and larger transaction fees because they will be operating on the larger amount of data in the contract. And if you want to traverse this list or jump into any portion of this list, that would be mapped onto a tree of cells. So you would have to jump through the references of this Ton cells, and this will be expensive operations. So every user will have a growing cost of working with your contract. So this is not the way you want to do it. And to help you, give you a guideline on how to properly design multi-user and large scale applications in Ton, there is the rule for working with lists. So the rule number 1, avoid having variable length data as a first priority. So it's very easy. If your contract has constant storage, then it has probably constant operation, and its rent and its gas fees are also constant and predictable, and it can work with the rest of the ecosystem quite nicely. Second, if you have to have a list, then at least make it short and bounded, like statically defined. Imagine a multi-signature contract where the participants to a contract are defined from the start. Let's say they're co-founders of a common enterprise, and there are 3 or 5 of them. They could have a list of their addresses with their voting rights or something, and this list is pretty much bounded, and it will not dynamically grow to millions of users. So that's also an affordable and reliable way to use lists in your contract. And third priority, if you need to have a list and it should be dynamically growing, then at least make sure that this contract is owned by a single user and they have the exclusive right to control its storage. A simple example are the records in the ton DNS items. So ton DNS, the main name, is a collectible non-fungible token that may have arbitrary number of additional records associated with it. So you can specify a public key, a public website address, maybe some additional attributes. And you as a user of this token, you're free to make this list as large as you want, but you're in full control. So there will not be any other user who would come in, increase the size of the list, and increase the cost for you of this token. So this is another similar example is the list of plugins in the wallets. So the wallet may install the plugins. They will be installed on behalf of the user. So the user is in full control. And so if the wallet operation becomes a bit more expensive, then the user could always remove some of the plugins. And there is no risk of denial of service attack from third parties. And if you really have a multi-user system, then you should truly avoid storing the list of users or user data in the contract right in a straightforward way. So what do you do? So the scalable way to make large lists or dictionaries of data in Ton is to use blockchain itself as an array. Here's a simple example. If you have a decentralized exchange and you want to keep track of each user's balance, then simply tokenize those balances. Create an individual contract instance for each user. They will take care of this as a token. Could be fungible, could be non-fungible, depending on your app. And then the users have to take care of paying the rent and operating this token. So this way, you've just split out your internal storage into arbitrarily large array of contracts, and your central contract becomes constant size. Similarly, if you have a system where users add data to common state, let's say something like an order book, this is something also could grow out of bounds rather quickly. So for this, you could also imagine a system where you have multiple contracts that are connected with each other, and every user is taking care of their own individual contract. And you don't have to store the entire list inside your central part of the application. The most popular example of implementing this idea is the design of tokens in Ton ecosystem. The tokens are designed in a way that there is a single minter contract, but this contract does not store a list of all its users. Instead, it's authorized to mint and create tokens for other users, and the balances of individual users are spread in so-called Jeton wallets. Those are separate contracts that are tied to the user's wallet as an owner, and they keep track of the individual balance of that user. And these contracts work together by sending messages between each other to transfer the balances by verifying their own code across the message boundary and trusting that if one contract sent the other one an instruction to increase the balance, then the sender correctly decreased the balance up front. So you sort of spread the logic of the token operation among those contracts, and each contract does their part. And what's cool about that is that the operations between two Jeton wallets in one place do not interfere with the operations of the other two in some other place, and they could be spread among the separate shard chains and not create any bottleneck. And the really cool part about Ton blockchain is that these scalable solutions are built with standard tools, and they're not special cases for special kinds of assets. They are universally accessible to any application developer. You could build your own kinds of tokens or financial contracts in this way, and they would be infinitely shardable as long as you keep each of your parts of the state a constant size and spread in individual contracts that are held individually by users or tied to a specific time interval or or a participant. So to conclude, the successful application that scales indefinitely consists of contracts with a constant storage and constant operating costs that in turn yields predictable rent and gas costs for the users, and therefore allows other contracts to compose well with your application. And if all the applications are predictable in this manner, then any sort of a complicated sequence of messages in the ton will have predictable costs for the user, and there will not be any sporadic failures in the middle of these chains, and the users will be happy, and your application will be successful and scale out to millions of people. And in the next lesson, we will take a look at the different specific instances where these ideas are implemented.